All right. Okay, can everybody see that?
Yeah.
You Sherpa, you there? Okay, great. So I've said all I'm going to about the nematoda. You might recall that nematoda is a phylum in a supergroup called the Ecdysozoa, and ecdysis is the Greek word for shedding your skin, for molting. Um, and the Ecdysozoa includes probably the two most successful phyla of all, the nematodes and the arthropods. Arthropods is, of course, insects and crustaceans and arachnids and centipedes and millipedes and trilobites and things like that. Nematoda we're done with. There's a few other phyla that are in there. Onychophora and Scalidophora don't have any members that are parasites. The tardigrada we'll talk about next time. They're called water bears, and they're really cool. And there's only two known that are parasitic, but that gives me a chance to include them, which I like because water bears are awesome. And the last, the nematomorphs, aka the horsehair worms, there's a chance you might actually see around Arkansas if you spend enough time poking around in ponds and puddles. So that's what we'll talk about now. And this will be fairly short. We'll end this one pretty quickly. So nematomorphs look like this. The larvae are parasitic inside arthropods, and the larvae look like little worms, but they bear a spined introvert. And you might remember this from the acanthocephala. An introvert is a part of the body that can be extended or kind of turned inside out and retracted by being pulled inward. Superficially, this looks like the acanthocephala that we talked about, although there's probably no close relationship between them. Adults are extremely long and thin, hence the common name horsehair worm, because they look, if you're on drugs, like a long hair from the tail of a horse. There's an old superstition that if you soak a horsehair in water, it will turn into a snake. As far as I know, this is not actually true, but it's probably based on observations of nematomorph worms, which are extremely long, thin, and swim kind of snake-like. The adults don't have a functioning gut. They don't feed. They just reproduce and then die. There are 5 species known that are marine parasites. I don't think a great deal is known about these guys, but this is a dissected crustacean, and that stuff in the middle that's coming out of the butt end of one of them are some members of the class Nectonematoidea. They're all marine. They don't, last I looked, they were not very well understood. They haven't been studied that much. Necto, by the way, is Greek for swimming, and Nectonematoidea can actively swim when they emerge from their crustacean host, aided by a double row of little bristles that give them a little bit more traction in the water. The fancy pants name is natatory bristles. Natatory is Latin for having to do with swimming. A natatorium is the fancy name for a swimming arena. You'd have a natatorium at the Olympic Games, for instance, and natatory bristles just means swimming bristles. The much more diverse class is freshwater, not marine. These are the ones that you can sometimes spot in Arkansas if you hit the right place at the right time. They're known as Gordioidea. If you know your Greek history, you might know that when Alexander the Great reached a particular city, there was a very complicated knot that I think had been tied by somebody named Gordius, and it was called the Gordian knot. And the prophecy was that whoever could untie the Gordian knot would rule the city. So Alexander promptly chopped the Gordian knot right in two and conquered the city, solving a knotty problem very easily. So anyway, Gordia, that root has to do with very complex knots. And Gordioid nematomorphs can certainly tie themselves up into rather complex knots. Now you know the rest of the story. As adults, these worms don't feed. They'll mate, and then females will lay strands of eggs, millions of eggs. Depending on the species, sometimes they may be laid in irregular shapes. But if you look carefully at this slide, you can see the eggs of genus Chordodes, which lays these eggs in these zigzag patterns, back and forth and back and forth. If you look carefully at that white stuff in the center of this submerged branch, you might be able to see that that strand goes to the left and then zigzags and zigzags and zigzags. Just a moment. Okay, somebody just went ding dong. Nick, you there? Okay, Nick, are you there?
Yes, sir.
Okay, sorry you're getting this late, but there seems to have been some kind of delay in the uca.edu mailing system. So it's only 3 people are here. I sent out my first message at a little after 9 and nobody got it until about now. So I'm kind of in the middle of things. We're talking about the phylum Nematomorpha. Okay. And before I run out of power, I'm going to there we go back to it. Nematomorphs and adults don't feed. The common name for these guys is horsehair worm because the mature ones are extremely long and thin and look almost like a long horse tail hair swimming around. And females lay strands in water. These are aquatic. The egg strands might contain millions of eggs, and one species that you could see around here has these zigzag egg strands. And the eggs can get fed on by a wide range of scavengers, arthropods, or snails. The eggs hatch into larvae. That's a larva over there on the left. On the right, the larva has fed on the host and formed a dormant cyst right there. That round thing is a cyst. It's a little larva kind of curled up in a little ball. There's a diagram. The outer part of the body is ringed. It's divided into 2 parts, a pre-septum and a post-septum, head and abdomen, basically. And on the pre-septum, there's a spiny introvert. And we talked about introverts with acanthocephalans, which are not closely related to nematomorphs. But the introverts are spined and they can be extended or they can be kind of turned inside out and retracted inwards, a little bit like you could do with the finger on a glove if you wanted. Okay, so the larva will live inside an intermediate host. It could be a snail, but it's often an aquatic arthropod. The larvae will eventually form cysts in the host muscle. And then when the host gets eaten by another host, typically a scavenger, which might eat dead insects like a cricket, cockroach, or beetle, the larvae will then hatch from their cysts, burrow into the new host body cavity, and develop into adults. And when the adults are mature, they will come bursting out of their host, sometimes several at a time. So there you've got a grasshopper with a Spinochordodes nematomorph bursting out of its butt. This is similar to the life cycle of myrmifid nematodes that we talked about a little bit earlier. Although whether there's a close relationship or not, I'm not entirely sure. But there are several species that are known to affect host behavior, where an infected cricket or grasshopper, or in at least one case I've seen on video, a spider, might deliberately jump into water. And as soon as it does that, the parasites come busting out of the things behind and swim off into the water. And this is the stage at which they can be observed in ponds and puddles and places like that. I've had students before that have noticed these. I have yet to see one live myself, but the adults are there's extremely long, thin, wriggling worms. As they mate, they may form these knots, hence the name Gordioidea, after the Gordian knot that we talked about. The adults can survive on their own for a few weeks without feeding. And there's a female posterior on the left and a male posterior on the right. The male butt ends in a pair of bristly lobes that are used to grasp onto the female and transfer sperm. A fertilized female will lay eggs in that zigzag fashion. And once again, it's the circle of life, and it moves us all. And I'm sure you are moved by the tale of nematomorph worms. And I'm going to stop there because my laptop battery is almost dead. Are there any really quick questions?
Concerning the lab assignment,
Mm-hmm.
are we considering them, the tapeworm eggs, are we considering them hatched when they're out of the second outer shell, or when they're out of the embryo four?
Let's do it just out of the second embryo shell. I should have clarified that.
Okay. All right. Thank
Yeah,
you.
when you can see the claws truly coming out.
Yeah.
Okay. Yeah,
Thank
that's when we'll do it. Okay, I should clarify that for everybody with an email to all.
Okay.
Okay, about to die here, so I'm going to.
Is that going to be due this Friday or next Friday?
Try to do it this Friday, although honestly, I'm not being a stickler for deadlines when we're also scattered and, still reeling from the chaos.
Okay.
All right, stopping recording now. Thank y'all for coming.